Thank you for introductory remarks. So I will directly, without wasting time, I'll directly start the presentation. So this is one of the important topic in the current industrial areas, and especially for any kind of construction activity, especially for bridge construction, the design and of the foundation, as well as the importance for any superstructure design. What is the importance of the geotechnical investigation? So here the main topic of the today is to the having some ideas, having some insight about the geotechnical investigation for the bridges. And this is basically from my past experience. I have done some work on especially two major bridges which are under construction right now. One is in between Assam to Meghalaya, that is in between Dhubri and Fulbari. It will be one of the India's largest river bridge, and as well as in the Bihar region, that's like in 𝗏𝗏𝗴𝗏 bridge, that will be also one of the longest bridge, around 8.6 kilometer on the river it will be. So there are different challenges when we will go for this bridge construction, and we need to consider many aspects before going to start the construction activity. So especially we will emphasize on the geotechnical investigation part, and main contents of the today's presentations are that objective of the geotechnical investigation. I hope my screen is visible. Can anybody just give me some confirmation that my screen is visible or not?
It's visible, sir.
Okay. It's moving, like the slides are moving?
No, sir.
Now?
No.
Now it is?
Yeah.
Is it moving?
Yes, sir.
Okay. Thank you. So the objective of the basic geotechnical investigations and different stages of this investigation, method of investigations, types of sampling, test methods, interpretation and reports, typical geotechnical problems. So these are most of the challenges we will face when we'll go for the bridge construction initially. As a geotechnical engineer, there you need to have some idea before going for the geotechnical investigation. Those major aspects we'll discuss today, and the importance of these challenges as well as the different critical aspects. What are the things we need to think about before starting their investigations? Generally we deliver this investigation process to some agency or some clients, and what are the things we need to take care, and what are the things we should consider when we'll go through that report, subsoil exploration or geotechnical investigation report. So coming directly to the first point, that what are the importance, because this picture, left picture, all of you must have seen the leaning tower of Pisa. That tilt of this tower it's very iconic tower, and there are like lot of investigation happened on this tower regarding, because this was the ideal case of poor geotechnical investigation, initial geotechnical investigation. So I hope all of you who have read the historical importance of geotechnical investigation, that this leaning tower of Pisa case study must you have gone through. So basically first part will be this investigation process is to make the safety. So as a designer or as a geotech engineer, our main job is to provide safety, safe construction, as well as the economical construction. So safety and economy, these two are very important, because one geotechnical investigation report, suppose for the one borehole constructing, so we need to go to the at least 25 to 30 meter deep, like either SPT or CPT. Then we need to find out the different layer by layer properties. So those things are also like very not costlier. So we need to very wise about selecting boreholes as well, and we need to think about the soil properties along the layers, along the depth of the soil. So the different objectives we can be it can be classified as the like suitability, design, existing works. So this is another important aspect. So of course, if it generally we call it as a green field if it is no construction or no other structures are present. But if it is some other structures are present, we need to consider the existing work or like existing structural aspect, as well as are there any interaction effect or like effect of changes and choice of the site, basically site locations where geology also involved, where geography also involved. So it's a very challenging part to select the site, and the methodology, of course. So methodology will also, of course, involve the economy as well as the time saving part also. So different stages of investigation, like the initial preliminary investigation, which is called, we call the reconnaissance. Like it's a important part, like interesting part for the surveyor also. That it's the whole surveying study will involve the day study and the site reconnaissance. So initial preliminary investigation from the site data, past data. So many times we check with the Google Earth data that whether there is, what are the types of soil stratum present, or like what are the present location of the water table, or like soil types and soil conditions, whether that is very heavy rainfall areas or whether it's very dry areas. Like, so those part will be the stage 1. Stage 2 will be the detailed investigation for the design. So we need to either like design will be by manual calculation or using some software. We need to provide some, we need to input some parameters. So from detailed investigation for the design will be the stage 2, and stage 3 will be the construction review. So of course, so here another subject or another component will come about the plants and machinery. So based on this investigation only, we will consider the different plants and machinery involved for this construction. So overall construction review. So first stage, we'll discuss about the first stage, that the day study and the reconnaissance, as I was mentioning about that maps and survey plans. So that is very important to understand the current maps and where it is located, what type of geographical and topographical stratum, or what are the rainfall parameters there, like how in the especially annual rainfall data, as well as the groundwater table information. Those things are important from the survey plans. So permitted use and regulation and permission. So this is very one of the important aspect. If it is this bridges are happening through some congested place or some urban areas, there must be some underground constructions or like underground utility lines, which we call the underground utility services. So there we need to find out that whether it is permissible or like whether we need to take some permission from respected authority. So another is the approach and access. So this approach road or access roads are very important, well, because we need to provide some construction for the construction activities and the mobilization of the machineries. We should provide that approach and access road. Otherwise, it will be very kind of time delay and operational point of view. We need to think about that part. Next one is the ground conditions. It's very important. From the photographs and images, now photographs and images, like nowadays a lot of advancement happen, like use of the drone survey, use of the LiDAR survey to get the more photographs, more detailed three-dimensional information about the location, about the site locations. Underground structure and utilities, this already I mentioned. Information related to the potential contamination. So this is very important. If there is some wasteland, there is some reclaimed land, there is some dump yards, so those things you have to consider, that potential contamination. So for this point, like I will say one example, that somewhere suppose there is some agricultural or fertile land. So we need to consider that whether this fertile land, through the fertile land we can construct, and there will be some emission, carbon emission also from those construction, whether it is allowable or not, whether this environmental boards will allow or not, and other contamination, potential contamination aspect we need to consider. Traffic control requirements. This is very easy to understand, that traffic control requirement, that due to that construction, that the areas or the existing traffic should not be getting delayed. So we need to consider the alternative arrangement regarding this traffic control also. So hydrological information, this is the another aspect, that hydrological, if it is having rainfall, like how to provide the drainage and what should be the drainage aspect, and different hydrological other information, that rainfall data also come under this hydrological informations. So local knowledge and resource sets. So for example, if we are constructing some site or constructing some some local construction issues, different local, using the local labor, using the local information, those are very important, and especially for the excavating the soil, information about the soil properties, and this local people knows much better on many aspects. So these are all like from the deck study and the reconnaissance survey, we need to understand all these informations. Now next part, this stage 1 and other aspect will be so what will be the outcome of the stage 1? So as I mentioned, there are 3 stages. The first stage is like that we need to find out the location and extent, like what would be the depth of the investigation, or what are the spacing of the investigation. So location and depth of the boreholes are decided on expected subsurface conditions, previous geotechnical information available, likely extent of zones in ground influenced by loading, need to achieve a reliable geotechnical model analysis, and the size and importance of the structure, and tender and contractual requirements. So each and every points of different importance, and say for example this tender and contractual requirements. Suppose from contractor side, some clients gave some criteria, that is, suppose this access road or the construction roads we need to deliver in terms of some maintenance gallery, or some kind of from the urbanization point of view, we need to plant more trees. Nowadays it's very mandatory to, from each construction site, we need to plant more trees to reduce the carbon dioxide emission. And say for example size and importance of the structure, that what are the structures, or like say for example there will be some box culvert, there will be some pier, some abutment. So what will be the size? So those things will come as the outcome of the this day study and the reconnaissance survey. So these are like for example likely extent of zones. So these things we will discuss again, like this is very this common concept about the pressure valve, that how much depth of the influence, or how much the depth we will consider for the termination level. Suppose we are considering pile, how we will decide about the depth of the pile. Suppose we are considering some well foundation, how we will consider the length or the termination depth of that well foundation. If it is some it is on the river, then we have to consider the highest flood level, HFL level, as well as the scour depth also. So from that point of view, like you can understand that this depth of the exploration, like which is very important part. So one will be this cutting depths, like how we are going to cut, available machinery, and the depth we are going for the construction, that excavation. Second one is the contaminated ground. This is very important. Suppose in some patches, some organic soils presented, some patches peat or organic soil, or some more chlorinated or sulfate prone soil, sulfate attack prone soil presented, then we need to consider about that contamination effect also. Size and importance of the structures, extent of influence, foundation type, embankment heights, expected subsurface conditions. So all these aspects we need to consider before going for the depth of the exploration. So like how will come out like the spacing and the depth. So this is a common plan, like the plan of the borehole, different numbers used to provide for the different boreholes based on the reduced level as well as the change. So you can see that the different boreholes, and the suppose this is the like road section. So the both side of the section we used to provide the boreholes alternatively, so that the spacing of the boreholes are maintained in such a way that all the areas, tentative areas, will be covered. So this is very important from the deck study and reconnaissance, that location and extent of investigation. So you can see that for this particular section, what will be the thing, like say for example this is a one plan elevation diagram I am showing that how these structures and how this depth have been decided for two borehole location for pier number 8, pier number 9, and P7, P10. So you can understand if this is some rock presented and or some hard stratum presented, we need to think about the termination level. The termination level will be decided based on that exploration report only. So these are the different aspect of that borehole location and borehole spacing. So from that point of view, spacing and depth of the investigation is very important to find out from the stage one of the investigation. So depth of the investigation exploration, there are some thumb rule or guidelines. So for example, for a foundation, for a structure or shallow foundation, depth of exploration below base of the footing or wrap is equal to 1.5 times width of loaded area. So these are very common, like 1.5 times the loaded area. And for the foundation, for the structure like pile foundation or deep foundation, we consider 1.5 times expected length of the pile. So this, say for example, length is 25 meter, then we need to consider up to 40 meter exploration. So since those will be the influence zone or the loaded region. So stage one, like I hope all of you understand the stage one, so different aspects. So it needs to be done very carefully, and all the things should be considered, all the above mentioned things. And you can consider, like you can note it down also, like from that point of view, that what are the important aspect and the thumb rule of this case study and site reconnaissance. So stage two is the detailed investigation for the design. So basically, I mentioned that from the stage 2, we'll have the information about that input parameter for the design and analysis. So like stage 2, like what are the different methods to carry out ground investigation? One is the excavation. Excavation means like open trial pits. Second one is the boring. Boring, there may be different kind of boring, like hand auger, mechanical auger, percussion boring, rotary or core bore drilling, wash boring. Third one is the probing. Probing means like static cone penetration, SCPT, standard penetration, SPT, dynamic cone penetration, DCPT, geophysical surveying, like seismic refraction, electrical resistivity. So these are different ways to carry out the ground investigation. So excavation, like as I mentioned, open trial pit. So it's like standard dimension of the open trial pit, and pits are dug by hand or by excavating equipment by hammering. So disturbed or undisturbed sample can be taken out from the pits. So pits are basically which we call in terms of technical terms to find out the representative sample. To find out the representative sample, pits are very easy to find out from the pit the representative samples. And these are kind of sampling. So from this point of view, we will get the sample of the standard dimension, which may be disturbed or undisturbed. So hydraulic rotary drilling rig. So these are different equipment. So coming to that, so investigation not only just proposing depth or proposing spacing. We need to think about the instrumentation and that plants and machinery. That's why which we call in short P&M. So hydraulic rotary drilling rig. So this is the kind of to find out to do boring by cutting action of rotating bit. So basically here high torque and less vibration. Second one is the calyx rotary drilling rig, boring by cutting action of rotating bit, easy to shift. These are very easy to shift. Second one, and the third one is the percussion boring, breaking of the ground by repetitive blows from bit or chisel. So especially advantageous when we will encounter some boulder or gravelly strata. So which will have the kind of will have breaking the ground by different repeating hammering action. So this hammer energy and like this kind of we can be controlled from the free fall height of the loaded hammer. So these are different method of investigation for boring. And probing, as I mentioned, probing like very commonly used adopted method or standard penetration test. I hope all of you are habituated with this standard penetration test specification, which we call the split spoon sampler. So 75 millimeter guiding rod will be fall down, and this 63.5 kg donut hammer, this manila rope, this tripod, ladder, pulleys, all are different component of the SPT. So why SPTs are commonly chosen? Because it has the low cost and this no instrumentation involved, availability of various correlations, and representative disturbed and undisturbed, both the sample can be collected. Few people are asking that network problem. So just for having more bandwidth, I'm switching off the video. I hope like it will work now. So like it has the low cost and no instrumentation, so simple manual labor can understand the methodology of the standard penetration test and very easily adaptable anywhere we can conduct this SPT. So that's why SPT is very commonly adopted methodology for this probing. And so after probing, so as a result of the standard penetration test, so correlation based different parameters, so it's like number of blows we are giving to the sample. So it's generally like it's well established that the very soft soil 0 to 2 blows, for the soft soil 3 to 4, and very hard means above 32 blows. So from that clay, as for sand based on the relative density, if it is very dense sand, it will be more than 50, and if it is dense and 31 to 50 blows. So number of blows will give you some ideas about that what type of soils have been presented under the ground. So standard penetration test, like this is the basic philosophy of the standard penetration test, is the kind of free fall, like considering that half MB square and equals to like V equals to √2GH. So basically we are converting that W weight of the hammer times the height of the free fall. So corrections to field SPT, we need to know very carefully that what are the different corrections for the SPT. So different corrections like this hammer efficiency correction, drill rod sampler, borehole correction due to overburden pressure, and correction due to water table. So those are very important to know that technical skill from that to find out to better correlation based parameter. So like from the standard penetration test or number of blows, we can have some estimation about the available bearing capacity, available safe bearing capacity also. So that will give you some idea before. So test based correlation will give you the values about the C and phi, about the density. So this will be input in the design, whatever the design tool you are using. So those input parameters will be found out from this detailed investigation report or stage 2. So SCPT or standard cone penetration test. So these are very important. Determine the in situ penetrative resistance of clay. For the clay, it is very commonly adopted because of the sticky nature. Sometimes standard penetration test is not suitable. So basically, cone is pushed into the ground at the rate of 10 to 20 millimeter per second, but it's not suitable for the dense sand. And there can be pore water pressure measure. Suppose there are some fine sand or kind of loose sand as well as soft clay presented, there may be high chances of liquefaction. So we need to measure the pore water pressure. So there can be added the piezo cone or piezoelectric device, so which will ultimately give you that SCPT and pore water pressure. So this is the one of the versatile tests. So this is the one sample of the piezo cone, right? One I'm showing. So this is the SCPT based correlation parameter. This is very well established that if we from the different zone we can find out the soil behavior. Sensitive to very steep fine grained soil, it can be classified. And this standard penetration test will give you the this type of log sheet, that based on this log sheet you can find out the QC, FS. FS is the sat friction, like side friction. friction. U is the pore water pressure. So dynamic cone penetration test. So this is another test, like this is alternative to both SPT and SCPT, where very large area can be tested very fast and helps in identify variability of the subsoil profile and to locate soft pocket. It is not suitable for more depths as friction along the extension rod is significant. So this DCPT is kind of another versatile test, another alternative test for the to have the large area, to consider the large area of the to find out that soil investigation report. Another thing is the about the geophysical test. So geophysical test or electrical resistivity test. So electrical resistivity test can be like having like some ultimately we are finding out that each type of soil has a different resistivity. So based on the potentiometer and the battery and the millimeter, we are trying to find out that the resistivity of the soil. So mean resistivity will come in terms of ohm per ohm centimeter. So distance between the electrodes will put on the soil, different soil, and we will measure the resistivity. So resistivity will depend on the water content, degree of compaction, and its composition. This is a schematic diagram of the geophysical test. Seismic reflection test is another geophysical test. Seismic reflection test basics are shock waves are created into the soil. Shock waves are picked up by the vibration detector. In dense strata, the refracted waves travel much faster. So based on that thing, we will have the refraction value, the refractive index value. So we can have that some idea about the geophysical test. So plate load test, another test for the bearing capacity assessment. Initial bearing capacity, we do assessment by using plate load test. So average contact pressure and settlement curve will give you the idea about the so that bearing capacity. So this is very important test. Like many cases, like foundation design, we need to do bearing capacity assessment from the plate load test. Now coming to the types of sample. So as I mentioned first, like it's kind of disturbed and undisturbed samples. So disturbed samples will not, so moisture is not retained. We are already disturbed its in situ stage. So of course, for the more accurate data, we need undisturbed sample, since it is not in situ stress conditions are preserved in the undisturbed samples. Core samples, block samples, these are important, and this is very important to find out that the core, that from the block or core sample, different importance are there. This core are important to find out larger depth and different variation of the properties. So types of sampling, like properties that can be reliably determined, we consider the class 1, like say for example classifications, moisture content, density, strain, deformation, and consolidation characteristics. Undisturbed samples are preferred. Class 2 is the classification, moisture content, density. Undisturbed samples are preferred. Class 4 only classification, disturbed sample. So you can understand that disturbed sample will give you the only classification, only strata identification. So if we suppose we need to find out the swelling index, or suppose we need to find out the consolidation parameter, of course we need to think about the undisturbed sample. Types of samplers, like the split barrel samplers are very common for the SPT test. The soil sample obtained is very disturbed type. Like that will have the tube sampler, thin tube sampler, like will give you the idea about that undisturbed type and should have very less inside wall friction and tube well lubricated. Core barrel, rock coring is done with core barrel attached to coring bit, generally double like a double tube and triple tube core barrel is used, and the standard core size is 54.7 millimeter. So core barrel, like if you can see the triple core barrel assembly and overshot, like whole core barrel assembly, triple tube core barrel is a good for obtaining core samples. In fractured rock and highly weathered rocks. So these undisturbed samples core box and core samples are very important to identify about this core barrel. So find out the index properties. So this is a very basic idea about the index properties. Like we need to find out the particle size gradation, define gradation through the 𝗙cie analysis and hydrometer analysis, and this will give you the idea about the different size of the particle. And this consistency limits like liquid limit, plastic limit, plasticity index, the Atterberg limits will be like different test methods are there, the liquid limit and plastic limit test. So ultimately, these consistency limits will give you the A-line chart to find out the name of this different symbolic classification of the soil sample. Particle sizes will give you the idea about the different soil descriptions. And shear strength of the soil will find out from mostly from the direct shear test, are very common for the sand. Excuse me. To find out the shear strength parameter of the soil. And unconfined compressive tests are very quick test to recommend it for the cohesive soil. And this will give you the idea about that the different in situ stress condition. So we need to consider this thing to have more in situ to replicate the in situ stress values. So settlement of the soil, this consolidation tests are more preferred tests to find out the settlement of the soil. So loading pattern. So I hope all of you are habituated. So this settlement behavior, like this stress applied, and how this settlement consolidation is the kind of naturally how the application of the water and application of the stress, it will have that consolidation process that which will ultimately settle, and will have calculate the settlement curve from the E log P curve will give you the settlement value. So now these are kind of all our common tests we have already discussed. Now these are kind of special tests. So chemical test of the soils and the groundwater samples. So pH is one of the tests, sulfate, SO3 and SO4 content, chloride content, organic matters, concrete and reinforcement may get attacked by chemicals present in soil and groundwater. So like this, understanding the terms that CR and the RQT. The R is the sum length of the core recovered and by length drilled. So this is the CR is the core recovery value. Core recovery value will give you the idea about the rock sample, different rocks value, like kind of this slightly weathered, moderately weathered, highly weathered. So this will give you an idea about the rock samples. And RQT value will give you the classification, the different classification of the type of weathering grades, whether it is excellent, good, fair, poor, very poor. So test on the rocks are uniaxial compressive strength, point load index text, dry density, porosity, water absorptions. So for the rock sample, there are different tests like unconfined compression test apparatus, point load index, UCS test. So these are different tests on the rocks, and interpretation and the report. Now these are all tests. Since we cannot jump directly to the report, I gave the overview of the test. Someone raised the hand, like any question? Okay, like I will give time at the end, like just note down the questions. We'll have the question and answer session at the end. So basically the interpretation and report. So overall project brief about the geography and the geology and the topography, seismicity of the project location. This is very important. Soil classification, soil parameters, subsurface stratigraphy, along with groundwater conditions, liquefaction assessment, and for the water under the construction of the water, silt factor and the scour depths. So these are very important to identify about these contents and the report. and continued with the geotechnical assessment like bearing capacity calculation, if it is pile load capacity calculation, along with that lateral load capacity also, ground improvement method. Suppose that from the investigation we were encountering some very weak soil or very soft soil, whether this will not have the enough bearing capacity, then we need to propose the ground improvement. So you understand that how much importance of this subsoil soil investigation report. And any other special recommendation like kind of that like chaining, that having more drainage, different drainage, providing different drainage path, or different other activities, other construction activities, or some special equipments or special plants and machineries are required. That is the kind of any special requirement that reports will contain consist all this information. So like these are kind of soil profiling, like these are commonly adopted bore log data sheet for particular bore hole, for particular termination depth, boring method. So all the things will be mentioned. Suppose some location like major bridge location, whether it is vehicle underpass or box culvert location. So this will give you the idea about the soil investigation report and the different layer by layer SPT test value, SPT sample N value, and then we will go for the corrected N value with the proper symbol, with the correlated symbol and the description, and that the grain size analysis, at-work limits, density and the moisture, specific gravity, shear test, free soil index, soiling pressure. These are commonly adopted tests, and commonly adopted report will consist of all these informations. The test results will look very similar to like this grain size distribution curve. Like this is a grain size analysis. So this will be kind of borehole number, sample type, sample depth, the sample description, percentage of gravel, percentage of sand. So all the percentage, D60, D30, D10, CU, CC, all the information. If it is an UU test we are conducting, UU triaxial test, then we will have this description about the cohesion, as well as the test result. We will find out the phi value also, C and phi. So like from the consolidation test, we'll have that E log P curve, from the phi log P curve, mostly by using the Terigaud's method. We will kind of find out that PC value, that from PC value we'll find out the settlement value. From the pre-consolidation pressure value, we'll find out the CC and CCS, and ultimately we will find out the settlement. So kind of this profiling, like if you have that, like in many company, if you have the initial days or initial to habituate with the design, you have to understand how to do profiling or layering. There are many softwares that there, many people do in Excel also, but it's very important to do this soil borehole profiling. This is borehole profile. So define borehole profile with the different depth. So this will be the depth, elevation depth part will be both the scale will be the vertical scale, and the different layer wise with the proper soil classification symbol with the N value we have to provide. So here you can see northing, easting, and the EL also level also like we have provided. So this is about the stage 3. So stage 3 is the biggest step, and like this construction review. So as of now we have discussed about the stage 2, that the detailed investigation report, what the things this report will consist. Now stage 3 will be the construction review, that during actual construction following the typical problem, that how to find out the founding level, founding strata. Say for example soil condition mismatch. Say for example these groundwater table conditions, there will be fluctuation. So difference in the ground levels and the founding levels. And this non-availability of enough ROW, differences in the topography. So variation in structure, size, type, location after geotechnical investigation and design. Changes due to other aspects such as hydrology, client requirement, which we call the change of scope, like COS. So this we need to understand from the geotechnical problems. So during actual construction, following are typical problems. So this we have faced in many ways, and like this, that's why we're having some ideas. So there may be some other particular site-specific problems also. So this is the kind of the content I need to deliver today, and these are like different soil scenario and the different based on the site's conditions. These geotechnical investigations we need to consider. So like I will share with the audience like what are the different questions. I will be happy to answer all the questions. Please share the questions if anybody has seen like any different scenario during these soil investigation report preparations. And it's very important for any interview or job perspective also to understand the soil investigation report. And many were at the first many people like there are like specific people they hired for to do the soil investigation report and having all the data assembled from the whole log dataset. Please share any other doubts related to this if you have seen this different things. So like for doing this accurate soil investigation report, like as much as possible we need to consider all the things very carefully and all are the kind of site specific challenges. And it since because of this natural variability we need to consider all the aspect like like challenging aspect. So like samples can be kept before taking to the laboratory, like maximum we keep it for not more than 24 hours from this collection from the sample, undisturbed sample. We need to preserve it through so the moisture preservation, and the undisturbed samples will be delivered to the laboratory within 24 hours. And that this is like how to calculate the depth of the exploration. So that like we have like as I mentioned like say for example we have decided that for example pile will be provided of like 1200 mm dia and as well as, and so here always like we'll always think about first from the construction point of view, don't go fast to the this calculation part. So suppose there are two types of pile. One is boring pile, another is the driven pile. We have to decide what type of piles we are giving. So for most of the cases, we go for the boring cast in situ pile. So say, okay, like boring pile, we have decided. Then from the boring pile, we need to find out that diameter first, the tentative diameter, like 1200 mm, suppose we have decided. Then we have to consider the loaded region. That's okay, like up to 2.5, 1.5D or to 2D, we have to consider the soil exploration report. And then how we will consider the depth of the exploration. Like depth of the exploration will be the based on the length as well as the depth, like this diameter of the, so basically it will control by the geometry of the foundation, geometry of the structure. Suppose it is we are going for the some reinforced retaining wall, then we have to provide the retaining wall foundation. So based on the stem length, based on the retaining wall's height, we have to consider those loaded areas. So mostly we consider from the safer side, we do better side, more like higher side of the depth. So preservation of the sample in the remote locations is very challenging. Sometimes we may lose some moisture because of the remote locations. But as much as I mentioned, from the collection of the sample within 24 hours, we used to keep it and like so that these moistures are preserved and in situ stays are mentioned.
Excuse me, sir. Sorry for the interruption. Can I ask students for the, can I take your few minutes so that I can ask for some information for students?
Yes, yes. Like this, okay, like these questions, they are asking many questions. Can you just have some, what are the platforms I can answer these questions?
I didn't get you, sir.
So these questions, I want to answer, you take, I will take the 5 minutes, after the your.
Okay, sure. After you, sir. Sure.
Yes, yes. So they're basically about the diameter and the length of the foundation. Who will decide this tentative dia and the length of the foundation? So these are very important. This length and the dia will decide it first based on the uh, geotechnical point of view, that okay, this is the available bearing capacity of the soil or available safe bearing capacity. So from that point of view, first design will be done. Then we will go for the structural part. So suppose we are going for the higher structures, or height of the structure is kind of 10 meter to 16 meter. So in that case, on the this question is more challenging for deep foundation like pile or well. So that point of view, we have to think about that the available capacity, bearing capacity, and we have to consider, we may have to do some trial design about the length of the foundation, or kind of for different depth will come into the picture, like this length. So basically where the strong stratum will be presented, say suppose pile. So if it is, we are encountering some strong stratum, so from the pile you understand that there will be two types of load capacity. One will be the point load, another will be the shaft friction. So where we are getting more load, point load capacity as well as the shaft friction, so we will terminate that level. And sometimes we need to fix based on the kind of already specified, and in general those things mostly specified by the client. They specified we need to provide this much length, and this kind of, in the tender document itself it will be mentioned about the type, or say for example you cannot do much about the type of pile, or you cannot do, say for example nearby offshore, nearby this marine structure. We need to consider all those aspects, for pile things, pile dimension, how we will provide it, what type of piles will be there. So that's from my side, and we can have the later also we can discuss on these things. Please inform in the group. Yes, that is from my side. Thank you all for joining. If any informations from my side, you'll be happy to answer. Thank you all for joining the sessions, and I hope in upcoming or more webinar or this type of important aspect we'll discuss.